Namaste and welcome to Apna Gurukul Maths One Little Step Toward Success. We are doing the chapter Polynomials, chapter 2 of class 9th NCERT. Let's begin. We have already discussed the remainder theorem and factor theorem and most of the other topics of the chapter. We are only left with the fifth video of the series, and it is algebraic identities when it comes to polynomials. Let's quickly get into the chapter, but before that, let's understand or let's recall what are the identities we have already learned and we should have already known by this time. So the number one is x plus y the whole square. It is obviously x squared plus y squared plus 2xy. X minus y squared is x squared plus y squared minus 2xy. Now we have seen a little bit modification in this when it comes to square root in the chapter number 1. I hope you followed me over there and you have taken care of that. Then when it comes to x plus y times x minus y, we get x square minus y square, and then if you multiply x plus a multiplied by x plus b, you will get x square plus a plus b times x plus ab. Now this particular fourth identity we have used in the factor theorem. I hope a little bit of a variation, but we have discussed this. I hope you remember that. Now there's one thing which we must be very careful. The right hand side of x plus y the whole square, this one is called the expanded form. Why the expanded form? Because it is in the form of polynomial where we have three different terms, right? Three different terms, and obviously it's a polynomial with two variables. All the powers you can see are whole numbers. Now this one, x plus y the whole squared, since you can also write it as x plus y multiplied by x plus y, you can see both sides we have linear factors, right? They are multiplied together and there's no addition involved, and there's only one single term we can understand like that because they are in multiplication. So that is called as factor form. I hope that makes sense. This is called as factor form. This is called as expanded form. In the second identity, this is the factor form. This is the expanded form. But in third identity, as you can observe here, this one is the factor form. Obviously, all in everywhere, left hand side is the factor form, and this one is the expanded form, factor form. I hope that is very much clear. Now, this one is a little important when it comes to this particular chapter what we are discussing right now, so that's why I discussed that concept. Yes, let's try to understand what are the uses of identities. There are basically two types of uses. One is computation, the other one is factorization. So computation, very quickly, x plus 6 multiplied by x plus 6. So we will just apply the identity x plus 6 the whole square. So x square plus 6 square is 36 plus 2xy is 6. So you will get the answer as x square plus 36 plus 6 times 2 is 12x. I hope that makes sense. Now this identity we can use the fourth identity which we have x plus a multiplied by x plus b. So this gets us to x square. Then we need to add a and b. So it's 5 plus 3 8x, and then at the end multiply them. So 5 times 3 is 15. See, in one step we were able to do the complete distribution process, and that's how we get to this identity. Now in this particular question, how can we proceed? You can write it as 105 100 plus 5 100 plus 5 multiplied by 100 plus 6. Once again, this is the same as x plus a, because one, what do we observe? One of the variable is constant. Over here 100 is the same in both the terms, and 5 and 6 are varying. So what will be the answer? 100 square plus, you add both of them, 6 plus 5 is 11 times, it should be x. So what is same here in both the terms? It's 100. So 11 times 100 plus 6 times 5 is 30. When you do this solution, you will get the answer. So 100 square is 1, and then 2 more zeros. 100 times 11 is 1100 plus 30. So the answer you get is this one, that is 11,130. I hope that makes sense. How quickly we were able to do the problem. That is what is the uses of identities when it comes to computation. When it comes to factorization, we have expanded form given, we have to convert it into the factor form. Over here, as you can observe, the factor form is given. We either expand it, or with the expanded form, we get to a specific result. I hope you are able to see that minute observation over here. So let's do the factorization. A square plus 4 plus 4a. We can very easily identify that somewhere we are trying to look for x plus y the whole square. But how? So we need to write, so x plus y the whole square, what is the expanded form? X square plus y square plus 2xy, right? We need to understand this in this. So over here, a square is already there. Can I write 4 in terms of square? Obviously, it's 2 square. Now that means the x is a and y is b. So let's verify whether 2xy is going to be 4a. If yes, we can directly write the factor form, right? So 2 multiplied by a, so that is the value of y and x, and obviously we need to find 2xy, so one more 2. 2 times 2 is 4, 4a. As you can see, we have clearly visualized, verified, I mean, that 2 times x is a multiplied by y is b. So that means the factorization will be a plus 2 the whole square. I hope that makes sense. Very easily we were able to factorize. Now the second one, it's a little bit tricky one. Now in the second one, what are the identities so far discussed where you have x a square minus b square, or x square minus b square? That's the third identity, right? So that means we need to look for a perfect square in x square and y square. So can we convert this into an x square form? Obviously we can. Let's try to do that. So can I write 36a square by 9 as 6a by 3 the whole square? Now, my question arises, why can we write that? We can write in that form because according to law of exponents, 6a to the whole square means the meaning of this particular term is 6a to the whole square divided by 3 square. So when we go for 6a to the whole square, we get 36a square, which is the numerator. 3 square is obviously 9. Similarly, we can write this one as b by 10 the whole square. So now we have x squared minus y squared. So we get the factors as 6a by 3 minus b by 10 multiplied by 6a by 3 plus b by 10. I hope that makes sense. Yes. So this is how we do this problem. Yes. So that is one such example. Now the third example, it's a little bit difficult, but yes, not very difficult. Let's clearly understand. Over here, we have a minus term and two squared terms. So somewhere we are trying to take help of x square minus 2xy plus y square. Yes. So can I write 49a square in terms of one number to the whole square? Absolutely. 7a to the whole square. Can I write 25b square? 5b to the whole square. Yes. So now if I write minus 2 times 7a times 5b, am I going to get 70 minus 70ab? Let's quickly verify. 7 times 5 is 30 times 35 times 2 is 70, and obviously minus 70, a times b is ab. That means it is exactly in the form of a square minus 2xy plus a y square. So what will be the factorization of this? 7a minus 5b to the whole squared. I hope that makes a lot of sense, a beautiful lot of sense. So now it's time for learning some more identities. So far, whatever identities we have discussed, you might observe we have only limited ourselves to quadratic polynomials, where the degree is maximum 2, as well as we have limited ourselves to binomial where we have only 2 terms. Let's now move to, first we'll move to 3 terms and more, and then we will try to move for more powers. Okay, we'll not move greater than cubic polynomial, but yes, let's move a little ahead. So some more identities. So here we have x plus y plus z the whole square, and this is the formula. But how do we verify that? Quickly, let's verify. So x plus y plus z square, what is the meaning of that? It is x plus y plus z is multiplied to itself 2 times. Yes or no? Now, whenever we have such a term, what do? We use the distributive property. I have been telling you all that distributive property is very, 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 very important property. So what does distributive property does? This x is going to distribute to all the three terms. So x is going to multiply to x, then x is going to multiply to y, and then x is going to multiply to z. So what happens? X times x is x square plus xy plus xz. Yes or no? Now this y is going to get multiplied to all the three of them. Yes, that is how we verify them. Okay, let's get going. So plus yx, or you can also write it as xy because multiplication is commutative. So we will write it as xy because xy we have already one. So we will try to make like terms. Okay, so y times y is y squared, and then y times z is plus yz. Yes. Now let's get going with some more terms. Let me move to yellow. Now this z is going to get multiplied to all the three terms right now. Yes or no? So this becomes plus xz, z times x is xz, plus z times y, z times y is yz, plus z times z is z square. Now what do we observe? We have xy and xy. So can I write, first of all, we will write all these square terms together, x square plus y square plus z square. And then we are going to write xy and xy. So xy and xy becomes 2xy. Xz and xz, we have two xz terms, so they becomes 2xz. And then we have two yz terms, so they becomes 2yz. And exactly that is what is the identity says. I hope the verification process is clear. Now, once the verification process is clear, we are very keen on how does the expanded form looks like. Now, when we are very keen at the expanded form, when we are using it for factorization, we just have to relate it to the expanded form. Whenever we are doing factorization, I showed you, right, how do we relate term by term, and that's how then we write the factor form very easily. That is how we do it. Now we also have one more term over here, x minus y minus z to the whole square. Now what do I say? Instead of doing this whole process once again, wherever we have y, why not substitute minus y? We can do this directly, right? Wherever we have plus z, we will substitute with minus z. Why am I saying that? Because x minus y minus z, the whole square, can I write it as x plus minus y plus minus z to the whole square? Now you might be thinking, why am I doing like that? Because we already know the formula for x plus y plus z. So I am trying to keep it in plus form. Instead of y, I can obviously keep minus y. Yes. So now we will substitute wherever we had y, we will substitute minus y in place of that. So that means x minus y minus z the whole squared can be written as, now x we are not changing, so this becomes x square. Now minus y square, it will obviously remain y square, minus z square, it will obviously remain z square, because minus z square is nothing but z square. Now coming on here, instead of y we are substituting minus y, so 2x times minus y plus 2x, and instead of z we are substituting minus z, plus 2 instead of y minus y, instead of z minus z. I hope so far it's making a lot of sense to you all. Now that is equals to x square plus y square plus z square. Now 2x times minus y is minus 2xy. 2x times minus z is minus 2xz. And minus, both are minus, right? Sorry, I forgot to write. Wait, yeah. Minus y times minus z is plus yz, right? So this becomes plus 2yz. So what is the new identity we have? X square plus y square plus z square. First three terms remain same. Then we have minus 2xy minus 2xz and plus 2yz. Yes, so this is the new identity we have just created. With the help of the identity we have verified, and that is how beautifully everything is connected. When we know one identity, we can create the other one. I would request for you, do not memorize the formula, just do the verification process once. You can understand what is the link, and you will not be willing to memorize the formula, because whenever you want you can generate these formulas. So why not generate the formulas rather than memorize it? Memorizing is always very difficult. Let's understand some more identities. Now, as I told, from quadratic we are trying to shift to cubic. Okay, so x plus y cubed, we have a formula, okay, over here. So how can we verify that? Let's quickly. X plus y cubed, can I write it as x plus y multiplied by x plus y the whole square? Yes or no? Obviously I can. So now I x plus y the whole squared, I already know the identity. So what is this? X square plus 2xy plus y square. You can obviously write it x square plus y square plus 2xy, because addition is commutative everywhere. The properties which we studied in the last chapter, you can the description, I have pasted the link for the last chapter as well. If you have doubt, you can go through that. Commutative property, all the properties which we have studied, every time we are using that. That is why we read the properties first. Okay, now we have to distribute it. So this x will distribute to all these terms first, and then y will distribute. So let's quickly understand how that distribution works. So x times x square will give you x cubed. X times 2xy will give you 2x square y, and then x times y square gives you plus xy square. And then y is going to distribute to all three of them. So now y times x square is yx squared. Y times 2xy will give you 2xy squared. And then y times y squared will give you y cubed. So what is the new formula we have? Let's bring the cubes together. So x cubed plus y cubed plus, do we have any like terms? 2x square y, and yes, obviously a yx square. Can I write it equal to x square y? Obviously multiplication is commutative, so I get 3x square y plus 3y x 3y square x. Why? Because you can see y square x and y square x. Yes, so now you might be seeing a little bit difference between this product and this product. So let's expand this guy and let's see what do we get. So x cubed plus y cubed plus 3xy times x, 3x square y, plus 3xy times y, you get 3xy whole square, means xy squared. So as you can see, what we got and what the formula says, it's exactly same, and hence verified. Now why am I calling it as a verification? Because we already have the identity. We are just trying to verify that yes, whatever we have studied is absolutely correct. Now in the similar way, you can also verify x minus y cube, or you can also do something which we did in the last one. Instead of plus y, we can write it as x plus minus y to the whole cube. And the formula which we have got, you can substitute it, instead of plus y, you can substitute minus y, and you will get the formula very easily. You can try to do that. If you have doubt, just comment down. I will explain that in a little video. Okay, now let's go on to solve a few questions. Now we have to write the expanded form of this. So expanded form, it's the easiest thing we can do. What is the, you just need to understand the formula. So the formula was, first square all of them, then multiply 2 times these two first, these two seconds, and these two at the end. That's all is the formula. So x cubed, sorry, x squared. So 3a squared is 9a squared plus 4b square, 4b to the whole square is 16b square. 5c to the whole square is 25c squared plus, now 2 times 3a times 4b. So 2 times 3 is 6, 6 times 4 is 24. Shall I write it in detail? Okay, quickly I'll write it. So according to formula, you can quickly take your, when you have noted down the formula, you can match it. How am I doing it? 2 times 3a times 4b plus 2 times 4b times 5c, and the last term would be 2 times 3a times 5c. Yes. So these are the terms. We'll quickly expand it. So we get 9a squared plus 16b squared plus 25c squared. It's a little longer, but it's okay. Plus 2 times 3 is 6. 6 times 4 is 24ab. Plus, now this is b, not 46. So 2 times 4 is 8. 8 times 5 is 40 bc plus 2 times 3 is 6, 6 5 is 30 AC. And that is all we have as expanded form for this particular question. Similarly, you can do this question as well for the formula which we found for x minus y minus z to the whole square. You can do that. Now, similarly, you can expand this a plus b the whole cube. Now, how does the formula goes? A cubed plus b cubed plus 3x square y plus 3xy squared, right? So again, 3a to the whole cubed plus 4b to the whole cubed plus 3a square x squared and then y plus 3x and b squared. I hope that makes a lot of sense. So that is equals to 3a to the whole cube becomes 3 cubed is 27a cubed, 4 cubed is 64b cubed plus 3 square is 9. 9 times 3 is 27 and 27 times 4. 27 times 4 we will quickly. 7 4s are 28. Carry over 2. 4 2s are 8 plus 208. Then we have a squared b. Yes. Plus 3 times 3 is 9 and this becomes 4. 4 times 4. 4 times 4 is 16. 16 nines are 144. B, wait, we have to, it is 3a actually. So 144 b square a. So that is the expanded form of 3a plus 4b square according to the identities which we have discussed. Now, you can similarly do it for 5b minus 3q to the whole cube. Now, let's quickly go through a few questions of factorization. Now, if we have been given such a expanded form, obviously we have to lead it to factor form. So first, we will compare it. Okay, how do we do the comparison? 8x cubed, can I write it as 2x to the whole cube? 27 y cubed, can I write it as 3y to the whole cubed? So what in which form is it? It is looking to be in the form of a plus b to the whole cube. That means we need to verify these two terms, 3a square as 3x square y, and we need to verify 3xy square. Okay, all these extra terms acts like a verification. So we have guessed the value of x could be 2x over here and it could be 3y. Let's quickly go through it. 3 times, if we have 2x to the whole square times 3y, what do we get? So 3 times 2x to the whole square is 4x squared times 3y. So 4 times 3 is 12 times 3, 36x squared y. Can you see that? We have this term. Similarly, we will try to verify this guy. So 3 times over here x, the value of x is 2x. The value of y is 3y to the whole squared. So that is equals 3 times 2 is 6 and 3 times 3, 3 squared, right? So it is 9. So 9 times 6 is 54 xy square. As you can see, that is the last term. So I can write this as 3 times 2x whole square 3y plus 3 times 2x multiplied by 3y to the whole square. Now you can mention using the identity a cube plus b cube, we get 2x plus 3y to the whole cube as our factors. All of them are linear factors and the same factor is repeated 3 times. That's all we have. The second question is also very similar. Over here just we get 2x minus y to the whole cube. You can try and verify this question. Now, when it comes to this question, this is a little bit unique one, but we will discuss this. 27p cubed, so 3p to the whole cubed. We have minus. So what will that be? Can I write it as plus minus 1 by 216? So 6 cube. So 6 to the whole cube. So this becomes plus, it will be 3 times minus 1 by 6 times 3p. If I do this, will I be getting 3p square? I'm sorry. Plus, it should be 3x square y, right? So we have guessed it as x is 3p, y we have guessed it as minus 1 by 6. So 3 times y square x, right? Minus 1 by 6 to the whole square, and x is 3p. Yes. So if we do this, are we getting as 1 by 4? Let's quickly do it. So this becomes, these two will remain same. Let's only verify this. So 3 times 1 and 3 times 2. 3 square is 9. So we get it as minus 9 by 2 p squared. Yes. So obviously it's in plus. So plus and minus will be minus. It is verified. Let's quickly understand here. So it says plus 3 times 1 by 6 squared is 1 by 36 squared. So minus will get cancelled out, times 3p. So 3 times 36 is 12 and 3 times 12 is 4. So what do we get? We get p by 4, and that is what? Plus p by 4, and that is what it is. So what is the answer for this? The answer for this is 3p minus 1 by 6 to the whole cubed. And that is how we prove it. If still you have a little bit of confusion, comment down. I'll make a little bit detailed video about this, because this concept might be at times a little bit confusing, but the only thing you have to remember is take the expanded form, compare it. Yes. Let's quickly go through some more identities which have been mentioned in the exercise in our NCERT textbook. Now the one of them is x plus y plus z, x cube plus y cube plus z cube minus 3xy is this big identity. Now what is the expanded form? As you can see, we have different terms over here. So this is the expanded form. This is the factor form here, right? One of the examples could be, suppose we have this as the expanded form. So the factor form could be this. We have two big factors. You can compare it, and it's very easily done. Okay. Now, if you have x cube plus y cube, then we have one more identity which says x plus y in the bracket x square minus xy plus y square. If you have to memorize it, I won't recommend, but yes, you can just understand a sequence. If we have a plus here, the linear factor is plus, and in the quadratic factor, the mixed term, which has the mixture of both the variable, is negative. Just the opposite in case of xy minus xy minus x cube minus y cube. Yes, let's try to understand the explanation. Verification, once again, you can do the distributive property. X is distributed and then y is distributed. Everything will get cancelled out. Okay, I heard you while making video. Let's explain it. Okay, so x plus y, this is the factor form. We will try to expand it. Okay, x square minus xy plus y square. So this x is distributed to all the three terms. So x multiplied by x square, we get x cubed. X multiplied by minus xy, I got minus x square y. X multiplied by y square, I got it as plus xy squared. Now I'm multiplying y to all the other terms. So plus x square y, and then it gets us minus xy squared and then this plus y times plus y square will give you plus y cubed. Now, as you can see, x square y is in minus and over here it's plus, so they get cancelled out. X y square is in plus here and x square x y square is in negative, so they get cancelled out. We only are left with x cubed plus y cubed, and that's the expanded form. That is what the identity also says. Similarly, you can verify x cubed minus y cubed as well. Yes, let's quickly go through a few questions. 27x cubed plus 125 y cubed. How can we write it as? 27 can be 27x cubed 3x to the whole power 3 plus 5y to the whole power 3. Can I write it like that? Because 5 cube is 125, y cubed obviously will remain y cubed. What will be the factorization of that? It will be 3x plus 5y and then 3x to the whole square, that gives you 9x square minus xy. So 3x multiplied by 5y, 3 times 5 is 15xy, and then 5y square, so plus 25y square. And that's how you get the two factors. Similarly, for this, we can write it as 4m to the whole cube, because 4 cube is 64, 4 fours are 16, 16 fours are 64, minus 343 is 7n to the whole cube. So this is for minus formula you can apply x minus y, and over here it becomes plus. So its factor form will be 4m minus 7n, and then when you multiply 4m square becomes 16m squared plus 4m multiplied by 7n, 4 sevens are 28 mn. This becomes plus 7n the whole square, so 49n squared. I hope that is very, very much clear. So over here x plus x cube plus y cube plus z cube minus 3xyz, we have to show this one. When you expand this, again as we discussed in the last one, you will get this particular expanded form. So that is how we do that. Let's quickly do the fourth question. It's an application of the identity 3. Let's try to understand how. Over here it's given as x plus y plus z equals 0. So we have to show x plus y, x cube plus y cube plus z cube equals nothing but 3xyz. So according to the identity, x cubed plus y cubed plus z cubed minus 3xyz is equals to this whole term. Now it says x plus y plus z equals to 0. If this is 0, whatever is multiplied to itself, because it's in multiplication, you can see there's a big bracket. That means its whole term is in multiplication. So 0 multiplied by anything is 0. So take the 3xyz to the other side. So you get x cubed plus y cubed plus z cubed. When 3xy goes to the other side, 0 plus 3xyz, you get 3xyz. And hence we have shown. So easy question, right? But we need to understand this particular identity. Okay, this identity is not a major identity. It will never be directly asked. Such question will only be asked where you have to indirectly show it. Yes, I hope the algebraic identities for polynomials was very, very much clear for all of you. Thank you so much for your patience hearing. This was Apna Gurukul Maths, one little step towards success. Thank you so much for your patience hearing. See you in the next video with the next chapter number 3, and obviously the problem solving sessions of chapter number 1 and 2. See you in the next video. Until then, keep smiling. Jai Hind.